Assalamualaikum and greetings everyone. My name is Rajidaini Muhammad Ghazi from UMK. I would like to share my research entitled Removal of Emulsified Oil in Wastewater by Corncop Carbon. Improper discharge of oil during various stages of its production, transportation and utilization from domestic or industrial effluent cause oil pollution. The high organic and inorganic content present in the effluent of oil lead to serious environmental effects, posing a threat towards aquatic and terrestrial life. So, in this study, agricultural waste were used to remove oil in wastewater. Agricultural waste have been converted and value added to act as natural adsorbent, and this natural adsorbent is cheap, environmentally friendly, and can be conducted easily, such as Corncop carbon. And it is lightweight, non-allergic, non-toxic, biodegradable and odorless. Therefore, the objective of this study is, first, to determine the potential use of Corncop carbon for removal of emulsified oil from the wastewater, to identify the various controlling factors that affect the adsorption of Corncop carbon, and to characterize the Corncop carbon using TGA, FTIR and SEM. Okay, emulsified oil has been break down to form oil droplets and dispersed in wastewater. According to 5th Schedule, paragraph 11(1)(a), under the Environmental Quality Industrial Effluent Regulations 2009, acceptable condition for standard A and B are 1 and 10 respectively. Therefore, treatment of oil pollution from industrial effluent is essential prior to its disposal. This study will use Corncop. Corncop is polyporous plant fiber that derive from corp and good performance and develop pores for the oil sorbent nowadays. And to determine the concentration of oil in wastewater before and after remediation, gravimetric method was used. Gravimetric method is quantitative analysis which is isolated and weighed, separating pure elements or compounds. For materials and method, first, wastewater sampling from fish cracker factory and wastewater in situ and ex situ characterization. Next, preparation of Corncop carbon at 450 degrees C. Batch adsorption for emulsified oil wastewater with different time, dosage and concentration. And determine the emulsified oil concentration using gravimetric method, and then characterization of Corncop sample using TGA, FTIR and SEM. Okay, this is the equation used to calculate the absorption uptake of emulsified oil. Q equal to C naught minus C initial divided by M and multiply by V, where C naught and Ci were initial and final emulsified oil mass concentration, V is the volume of the wastewater sample, and M was the mass of Corncop carbon. To calculate the percentage removal of oil, this is the equation. Percentage removal, Ci minus Cf divided by Ci times 100. Ci represented the initial concentration of the sample. Cf was the final concentration of the sample. Okay. Table shows, we move to results and discussion. Table show the physical and chemical parameters for the wastewater. There are 3 parameters that exceed the threshold critically, which are COD, which are oil and grease, suspended solid, which is 3,383, and the standard limit only 10, and suspended solid 327, which is the standard limit is only 100, and COD, which is not listed here. COD is 3,415 milligram per liter, which is standard limit for COD is 100. The high level of ONG content, this is ONG content, was a result of the cooking oil used using the during the boiling process, which is then led to a high level of COD. Okay, figure shows the percentage of emulsified oil removal with different contact time from 1, 2, 4, 8, 16 and 24 hours. The highest percentage removal with the carbon was 96% after 2 hours contact time. Therefore, it can be represented as 6 mg of oil, emulsified oil remaining and considered as permissible compared to the standard, which is 10. Therefore, 2 hours contact time was selected for the next experiment. And this figure show the absorption uptake of emulsified oil increased from 16.9 milligram per gram to 17.1 milligram per gram when contact time increased and reached equilibrium after 2 hours. The absorption and desorption process on the carbon surface reached equilibrium after it was saturated. And these results also agreed with works by previous research who stated that the amount of oil absorbed per unit mass of carbon increased at lower times before reaching a plateau. Okay, this figure show percentage of emulsified oil removal with different dosage of concord carbon. We can see here that control experiment showed 87% removal, while sample experiment showed 96 removal for all dosage of concord carbon. From literature, when the carbon dosage increase, the percentage removal should increase due to the more available binding site for absorption. However, in this study, the removal remained constant. It might be due to the mass of the mass of the carbon is not significantly different. If we increase the dosage of carbon up to 10, maybe the percentage removal also increase. Okay. Next, this figure show the concentration of wastewater, the different initial concentration of wastewater with removal of emulsified oil. The percentage of emulsified oil removal declined slightly due to the increase in emulsified oil wastewater concentration from 5% to 30%. The removal percentage for control experiment dropped from 87 to 78%, while the removal for sample experiment declined from 96 to 82%. The reason for the reduction in oil removal is because of the saturation of active sites by the adsorbents at higher concentration onto the adsorbent surface. In addition, a prominent decreasing trend was observed in this figure. which justified the decrease in oil adsorption uptake with increasing initial concentration of emulsified oil wastewater. These findings was in line with a study by Olufemi, which also reported a reduction of emulsified oil uptake via adsorption with higher concentration of emulsified oil wastewater due to fewer adsorption sites at higher oil concentration. So next is the characterization of Concord carbon. TGA shows firstly 3.5% of the mass was lost within 30 degrees C to 150 degrees C due to moisture loss at this stage. And secondly, a significant mass was lost at 58.1% from 180 degrees C to 550 degrees C due to the degradation of raw concord and distillation of oleophilic material. And moreover, the sudden increase in mass loss was due to the release of volatile components such as CO, carbon dioxide and other hydrocarbons. And lastly, there were mass loss after 550 degrees C. The main thermal decomposition of the raw concord was because of its intrinsic hemicellulose, cellulose and lignin. And the pyrolysis temperature of hemicellulose is 200 until 280 degrees C, cellulose at 280 to 300 degrees C and lignin at 380 and 500 degrees C. Okay, this is FTIR results for Concord carbon before adsorption and also after adsorption, which we can see here that various functional group present in this raw concord, and the value of most of the value increase after adsorption of oil. Okay, figure show the surface morphological structure of raw concord before adsorption and after adsorption. This is surface morphological structure of raw concord. We can see here that there were irregularities and no pore observed on the raw concord surface. However, surface morphological structure of Concord carbon, which is after adsorption, before adsorption, we can see there is the formation of pore existed in Concord carbon, and we can see here surface morphological structure of Concord carbon after adsorption. The formation the porosity of Concord carbon, we can see here the sticky layer can be observed. Sticky layer can be observed on the Concord carbon surface as presented in this figure. That means the oil adsorbed to the surface of activated carbon. Okay, for the conclusion, the optimal parameters of emulsified oil removal was obtained, which is 5% concentration of emulsified oil wastewater, 2 hours contact time, and the use of 1 gram of corn cob carbon, and the maximum percentage of oil removal reached 96%. And it also can be concluded that 6 mg per liter of emulsified oil left after absorption process, which was allowable of the limit of EQA. So, as a conclusion, corn cob carbon can be alternative cheap treatment to reduce oil and grease in wastewater. That's all from me. Thank you.